This is my Japanese lantern that I have set as a solar light outside my apartment.
So this is what's going on inside the lantern itself. I removed the prototype board here along with the rechargeable battery over here from the inside that I keep here. This is the solar panel which sits on top of the lantern. What's happening is the solar panel comes in, it goes into this area here, it then comes across, it both was originally supposed to be charging the battery, but I'm not getting enough sunlight, so it's more acting just as a light sensor. When it goes below a certain voltage, the Attiny, which is on a sleep mode of every 8 seconds waking up, checks the voltage of the solar panel. And if it's low enough, it means that it's nighttime, and then it switches on the light. It does have some conditions to check the battery status. If the battery is below 3.4 volts, it's going to turn on this red LED indicator. And if it goes below 3.2 volts, it should shut off or just keep in sleep mode perpetually. One of the things that I did here, though, was I did put a Zener diode before the pin, checking the voltage. And I did that in order to prevent too much voltage from coming in to the pin itself, although I doubt that that ever actually happens. It's generally running around 1 volt, 2 volts coming in, unless you're getting, very intense direct sunlight. Perhaps it might be charging, it might be giving a few milliamps to charging up the battery. I'm a bit skeptical of that, but it's quite possible. So in this video, what I'm going to do is to go through the code used to switch on and off the LEDs on this. I'm going to reprogram a Attiny25 with that code, just because the Attiny85 that I have in it, it's a bit much for what I'm actually doing. It can hold up to 8 kilobytes of memory, and the actual code is running just under 2 kilobytes. And the 25 is perfectly capable of doing that. It has the same pinouts, the same VCC same VCC voltage check. So all I need to do is to reprogram this and stick it in here, and it should run for going forward just as well as that 85 did. So let's go ahead and take a look at that code, and then we'll come back and make sure that this is actually working.
So this is the code here for the Japanese lantern, and let me go through this with you line by line. We start off by including the library for the sleep mode, the power mode, and the watchdog timer. So this is to put it to sleep, this is to check the power, and this is also to wake it up, the watchdog timer. And I'm going to clear out the bits so that it can go to sleep. And how long we're going to leave it on for. So we're going to leave it on for 4.5 hours approximately. It's going to be give or take a couple of minutes. And I'm going to define this as a number of cycles. So how many times is the loop going to run? It's going to run 1,620 times. And the reason that I'm doing that calculation is because if we see here down here, the loop is going to run, or the delay in the loop is going to be just under 10 seconds. And this is going to compensate for the reading of the voltage, which we'll go through in a second. So we have 1,620 cycles. I'm going to set which pins are for the LED indicator light, the red light. And I'm going to set which pin is to power the candle itself. I'm driving both of these directly from the Attiny. This is the function to read the voltage off of the VCC pin. With the Attiny25, 45, and 85, you can read the voltage on that VCC pin. This is setting the watchdog timer, which is going to stop the sleep cycle. So this is the amount of time that it's going to cycle in the watchdog. So the watchdog will wake up every few seconds and just do a check of the VCC voltage. It'll do a check of the solar panels to see what the voltages are in there. And I have it set for 8 seconds. This should be an 8 over here. So every 8 seconds, it's just going to wake up and do those checks. All right, so this is the basic setup for the code. We're going to reset the watchdog. we're going to set all the pins to output pins. So I'm going to set the pin number 3 as an input, and that's going to read the number or the voltage of the solar panel, which I'm using like an LDR or a light detector. Okay, here we're reading in that value of the solar panel. We're going to convert it over to something more readable. We're also going to read in the voltage on that VCC pin. Now we go ahead and we do our checks and decide which of the pins we're going to output to. Are we going to output to the red pin, or are we going to output to the candle? So I'm checking the solar voltage. If the solar voltage is above 0.78, in other words, it's daytime, I'm going to reset the number of cycles to that 1620, which is 4.5 hours. I know it's daytime, so just turn everything off and then go back to sleep. Otherwise, it's nighttime. I'm going to switch on the candle. And I'm also going to check if that voltage is low, and I'm going to turn on the red light or the red LED if it is low. Okay, otherwise I'm going to keep that off. And I go ahead here, I start the delay of approximately 10 seconds, and then I reduce the number of cycles by 1. And then it just does this again and again and again and again until it reaches out of that 1620. So it's actually, I have it set for less than 10 here. So if those cycles, if it's run the number of cycles approximately 610, it's going to switch it off here in the go to sleep. If the voltage is less than 3200, which is 3.2 volts, it's going to go to sleep. If the solar voltage is greater than 0.78, it's going to go to sleep. So first it's going to reset the cycles before it goes to sleep in the case of the solar voltage or it being daytime, but otherwise it's just going to turn everything off and go back to sleep, which is going to make our consumption of the battery very low. So a very simple program. When I compile it, it comes in at just under the amount that I can get away with for a Attiny25. It comes in at 2026 bytes. So I should be able to load it up on an Attiny25, which is what I'm going to switch to for this project.
All right, so I'm going to pull out the battery here before I put the chip in. And let me just pull out the 85 here. And now I'm going to go ahead and stick in this 25, and it should go right in here to the dip. Okay, perfect. Now the footprint is a bit taller, but it should fit in to the base of the light. And now I can plug the battery back in. All right, and let me just cover it up. And hopefully it will start running in a second or two. There you go. So works perfectly fine. If I uncover it, okay, happen to catch it quickly on a cycle there, cover it up again, it should switch back on after a few seconds. Yep, so that's working well. So the question that I have for you guys is, I made these PCBs. These are generalized PCBs that I talked about in another video that I made for all these different projects. They all have very similar designs. They all use a TP4056 module. They all use an Attiny to power an LED or a series of LEDs. And they all have some sort of input sensing. So in this case, it would be solar. And the other one, I'm using a PIR. So the question is, this is working perfectly fine. It's been working fine for months. The question is, do I go ahead and move this over to this? I've done it just playing around for another project. It obviously looks much neater. It's much cleaner. But, you know, from a standpoint of actual application usage, this seems to be working perfectly fine. So, you know, do I go ahead and convert it over into a PCB? Let me know what you think. Comment below. And if enough of you think, yeah, sure, go ahead and do it, I'll go ahead and do it and move it on over.